Okay, so today we want to venture into the new topic, that is the Ohm's law. Are we together? So Ohm's law states that voltage is proportional to current and resistance. So which means voltage equal to current, then what? Current times resistance. Current times resistance. So this means that voltage is proportional to current and resistance. Are we together? So in simpler terms, we say V equal to IR, which means that this I represents voltage. So V equal to voltage. V represents voltage. I represents current. Then R represents resistance. That's the law. So when we are now looking for resistance, we can do, for example, then Ohm's law states that resistance equal to, now we are doing a subject formula, equal to voltage over current. Voltage over current. That's R equals to V over I. Are we together? Then current equal to voltage over resistance. So if you know this formula better, you can use what we call subject formula at each and every interval. If they ask you current, you can do a subject formula, then you come up with voltage over resistance. If they ask resistance, you do a subject formula, then you come up with voltage over current. These are formulas. So this is all about the Ohm's law. It says voltage equals to proportion. Voltage is proportional to current and resistance. Then after that, we say resistance equal to voltage over current. Then also we say current equal to voltage over resistance. But as we have this Ohm's law, as we move, we have what we call limitations. Limitations of the Ohm's law. Which means the Ohm's law, this law was propounded by someone, but one way or the other, a theory can have defects or disadvantages. Are we together? So these defects are called limitations in other words. So number one, temperature of the conductors changes. We said voltage equal to current times resistance, which means voltage is equal to it means that voltage is proportional to current and resistance. But at times we cannot say current and resistance are proportional because the temperature of the conductor changes. So it means resistance, by the time temperature increases and by the time temperature decreases, our voltage and whatsoever will be affected. Are we together? Also, the conductors are coiled. For example, those electrical bulbs or whatsoever, they have a coil to conduct. So it means that the conductor does not have a uniform cross-sectional area, so that we say voltage is proportional to current and resistance. Because if the cross-sectional area is not equal, it means that current and voltage is not also equal. Also, the conductor is placed under the strong magnetic field that alters the internal structure of the metal so that its conducting capacity changes. What are we saying about this? We are saying that for electricity to flow at certain times, they can be placed under magnets. That we can see that we have a North Pole magnet and a South Pole magnet. Then they use a coil or a current conducting wire in between so as to increase its capacity. And are we together? So it means that voltage is not proportional to current and resistance because now we have a magnetic field to improve its conductivity. After that, we have what we call factors which influence resistance. Factors that influence resistance. Factors that influence resistance. Okay. We have length of the conducting wire, it influences how long the wire is. Also cross-sectional area. When you are talking about cross-sectional area, if the conducting wire have a cross-sectional area like this, its resistance will be different to the conducting wire which have a cross-sectional area which is bigger like this. Are you together? So factors which affect resistance, we have factors which affect resistance. Number one factor is material of the conductor. It affects the resistance, the material of the conductor. How? Examples of conductors which are metals, which are allowed when you are passing electricity from one point to another. Materials which are required, mostly we need copper, aluminium and whatsoever, which means all materials which are not copper or aluminium or silver are not allowed to be used as conducting wires. Are we together? Also, length of the conductor, it also affect resistance. For instance, a long piece of wire has more resistance than a short piece of wire. Then we have temperature of the conductor. A material with a higher temperature is more resistance than a material with low temperature. Again, thickness. A thin wire like the two. Let's say this is a wire and this is a wire. A thin wire is more resistant than a thick wire. Are we together? Right. Then connection of resistors. We want to deal with the connection of resistors. We want to deal with the connection of resistors. Connection